What if reality isn't what it seems? What if the chair you're sitting on, the air you're breathing, even your own memories and thoughts, are nothing more than lines of code running on an unimaginable computer? This is the question behind simulation theory, the idea that our entire universe, down to every particle and every thought, could be an incredibly advanced simulation. For most of history, questioning reality was the job of philosophers. Plato gave us the allegory of the cave, prisoners chained in a cave, mistaking shadows on the wall for reality itself. Descartes asked how we could ever be sure we're not being deceived by an evil demon manipulating our senses. But in the 21st century, these thought experiments have evolved from abstract musings to real possibilities. That shift is largely due to our own progress with computers. In just a few decades, we've gone from pixelated Pong to photorealistic 3D worlds, virtual reality, and AI-generated environments indistinguishable from the real thing. If we can already simulate entire worlds at a crude scale, what happens in 1,000 or 1,000,000 years of progress? This question was formalized by Oxford philosopher Nick Bostrom in 2003. He argued that at least one of the following three statements must be true. Human civilization never reaches the technological maturity needed to create realistic ancestor simulations. Civilizations that do reach that maturity have no interest in running such simulations, or we are almost certainly living in a simulation already. Why? Because if even one civilization creates millions or billions of simulated worlds filled with conscious beings, then simulated realities would vastly outnumber base reality. Statistically, it would be more likely that we are one of the simulated beings rather than one of the rare beings in the original universe. So how could this work? Imagine a civilization thousands or millions of years ahead of us. They might possess computing power far beyond our comprehension. Instead of running one simulated world, they could run millions at once. Each simulation could be as rich and detailed as our universe, or even richer. The hardware might not resemble our computers at all. It could be quantum-based, energy-based, or something we can't yet conceive. Instead of simulating every particle individually, the simulation could be clever, rendering detail only when it's observed, like a video game engine only rendering what's in your field of view. This would dramatically reduce the computational load, making vast worlds possible without infinite resources. And here's the striking part. This kind of optimization already exists in nature. Quantum physics tells us particles don't take on definite states until they're observed, a phenomenon some scientists liken to a kind of cosmic, lazy rendering. While this isn't proof, it's an eerie parallel between how simulations work and how our universe behaves. Proponents of simulation theory point to several oddities about our universe. Space and time might not be truly continuous. At the smallest scales, the Planck length and Planck time could be the pixels and frames of reality, suggesting a discrete underlying structure. The speed of light acts as a universal maximum speed, much like the refresh rate in a game. Physics is written in the language of math, clean, precise, and often strangely elegant. And in quantum mechanics, outcomes are probabilistic until observed. Some liken this to a simulation that only calculates reality when needed, conserving computational resources. Then there are the subjective anomalies people love to cite: déjà vu, bizarre coincidences, the Mandela effect, large groups of people remembering events differently from recorded history. While none of these are evidence, they resonate with the popular idea of glitches in a simulation. They highlight just how easily our perceptions could be altered inside a controlled environment. If we are simulated, who built this? Are they scientists running experiments, ancestors studying their past, or beings with motives beyond our understanding. If we ourselves one day create simulations of conscious beings, and with AI and brain simulations, we're moving in that direction, we will face staggering ethical questions. Would the suffering of simulated beings be real? Would their lives have moral value? And if we're in a simulation, does that mean our lives are meaningless? Not necessarily. A simulated experience is still an experience. Pain feels like pain, love feels like love, regardless of whether it's built from atoms or code. Of course, there are skeptics. Some argue that simulating consciousness may be impossible, no matter how powerful the computer. Others note that simulation theory is unfalsifiable. By definition, a good simulation would hide any evidence of its artificiality. Even the clues we think we see could simply be features of a natural universe. Still, as our own technology races forward, we may reach a point where we can run smaller, sandbox universes ourselves. If we create conscious beings inside them, it would make Bostrom's argument even harder to dismiss. Whether we are living in a simulation or not, the theory forces us to think differently. It challenges our assumptions about reality, free will, and our place in the cosmos. Are we the creators, the creations, or both? Could our pursuit of knowledge one day lead us to the ultimate spoiler, the discovery that reality itself is a program? Simulation theory may never be proven, but it's one of the most powerful ideas of our time. It shows us that the boundary between science, philosophy, and technology is blurring, and that the nature of reality may be far stranger than anything we've yet imagined.